Hi, Stuart here. Today we're going to talk about resiliency, or how to make your .NET code cloud ready. So here's where you can get the sample app. Why are we doing this? Because as we've said in previous videos, networking is different than the cloud, and even in a data center, you can have transitory problems, and our code shouldn't die, right? Just because it can't connect to something, maybe it ultimately, if it really can't connect for too long, it should throw an exception, but it should reset itself to a sane state and wait for the next unit of work, the next call, whatever. So, you do a gentle retry on failure. Typically, you do some sort of back off, exponential or otherwise, and you do it a certain number of times. And then after that, you throw the exception that you just can't connect. So our demo is going to show some tactics for this. And again, you can go to the GitHub and download the demo and play with it yourself. You're welcome to all the code in the demo. Hey, as always, we're going to start Docker for Windows. Okay, now we're going to go into our scripts directory and start our Microsoft SQL Server Docker container and load the Blitzkrieg Bicycle demo database into it. Great. Now that that's done, let's open up SQL Server Management Studio, and what we should see is that on the default SQL Server port on localhost, we will have our SQL database loaded, and Bicycle will be in place, all ready for our demo. And there it is, the Bicycle database running in our Docker container on SQL Server 2017 for Linux. I like that SQL Server because it is compact and tight and well behaved and perfect for demoing. You can see that we have some tables. So for example, we could look at our customer table and you can see that we have a row in it. And so now that we know our database is up and running, we can get into the code. Here is our demo, the way it comes up. And we have this data directory, which is mounted in the Docker container as /data, and it contains the backup, the restore SQL script, and the restore shell script, which are executed when our SQL server starts. So the /data drive matches the relative path of the /data drive of the solution on your disk. So that's a nice way of doing that. And that's a fun thing to study, but outside of that, we have an info folder that's got our README and the license file in it, and we have the scripts, including the SQL start command that you saw running. We also have commands that let us start a bash prompt or a SQL prompt on our Docker container, which is great for debugging. But the main thing that we have is a web API written in .NET Core 3.1 ASP.NET, and we're going to go ahead and run that, and I will show you what it looks like. Okay, in addition to the usual Blitzkrieg common stuff, like the ability to get the version information from our website and a health check, which is a fine thing, we have some demonstrations. So we have a demonstration in Entity Framework, a demonstration in ADO.NET, and a demonstration in HTTP. So let's go through them one at a time, and we'll look and see where we have put our reliability code. We haven't had to add very much code in any case. So let's go take a look. So if you do a search on //c semicolon, you will get this output that shows all the places that we have marked as being resilient. And we're going to start with a quick tour of startup. We're going to take a quick look at our Entity Framework and ADO code, and we'll stop off on each of the three things: to database methods and one HTTP method and see how it all works. So first things first, startup.cs. Place number 1 is in startup, where in our services collection where we add HTTP client. We have to use a typed client as but it's completely a placeholder. So HTTP caller and HTTP caller we don't actually use. We just can't set a retry policy and handler without anchoring them to a typed client. And that typed client will get injected, and that's the one we'll end up using. But we don't actually need it. So we'll set a handler lifetime of a second. We'll set a policy handler of HTTP retry policy jitter get retry policy, and that's where the actual magic happens. So let's go take a look at our jitted retry policy. So here is our retry policy. What's a jitter? A jitter is a little bit of randomness so that in the case where we're starting up our service, but we're starting up, say, 7 instances, that the retry policy will get offset slightly by a certain number of milliseconds, so they're all not trying to do it at once. So that's what jitting means, is just to jitter around the time. So you can see in get retry policy that we return an HTTP policy extensions. We tell it we want to handle transient errors, so those are errors that happen very briefly. Or if we get a gateway timeout error, we want to wait and retry in 5 seconds. And we want the retry attempt to be an exponential backoff. So we have a retry attempt that's 2 to the power of the number of retry attempts in seconds. So that's an exponential retry. And we're going to add a slight jitter, in other words, a random number of milliseconds to that. So again, we're all not trying to do it all at the same time. And I apologize for a little bit of noise in the code in terms of some pragma statements, but I didn't want to disable the warnings, but I did want to point out why I get to ignore certain warnings and not others. And so in the style we use, we put our explanation as the first pragma line, and we put the original complaint as the last pragma line, so you can see at lines 28 and 30 that we explain what we're doing. So this is the policy that will be used to retry connections from our HTTP client factory. So anytime we make an HTTP client, this retry policy will be attached, and we will gain resiliency through that policy. So let's go to the controller for HTTP, and we'll open up our controllers folder, and we'll go to the HTTP controller. You'll see these things are pretty much eponymously named. And you can see we're injecting an HTTP client factory and setting our local factory. And then when we need a factory, we're calling this .factory create client, setting URL, and doing all the usual things. Right? So we're calling get async on that. And I'm doing this all synchronously because I want to make it easy to step through. And we're going to end up getting content read as a string, and we're going to return that JSON. And notice that I am using a produces tag to set the return type. So that's it. We didn't have to clutter up our code with a lot of retry things because we were able to attach the retry policy for HTTP directly in our startup and write our own custom retry class. And again, you're welcome to reuse mine, but you may find you want to tune yours a little bit. So that's resiliency for HTTP. So for Entity Framework, I generated my Entity Framework classes in a different project and then transplanted them over. The scaffold context command is really picky. It will only scaffold context into an exe, and that's really annoying. But as a workaround, what I do is I go into my temp directory, make a throwaway exe, scaffold my Entity Framework project, and transplant my classes into where I actually need them. Sometimes I put them in a library, but in this case it was just easier to put them in a folder. And these are all table classes. And so what we're really interested in, though, is the context object. And we made some changes to the context object. First, because I want to enforce passing the connection string into it. And so I have made the normal constructors to be private because I don't want people to call them. And instead, I've made two replacement constructors that you can call. One that has a connection string and the other one that has a connection string with options in case you want to set some of the options. So we do that. And we inject our logger factory, iLogger factory, so that we have it when we need it. So then we have a block of database sets where we declare our DB sets for all of the tables. So for all the rest of these files, we have that. And what we really care about, though, is the onConfiguring event. So we're going to have our onConfiguring event, and it's going to set up our retry policy. So we're going to tell it we want it to use the logger factory we passed into it as our logger factory. And we say we're going to use SQL Server, and we're going to use the connection string we passed into it. And then we're going to set some options. So we're going to set the command timeout to a minute. I could have said time span from seconds 30 total seconds. That would have worked too. And then I say, well, I'm going to give it 3 tries and I'm going to back off by 5 seconds each time. And I'm not going to add any special error numbers to it. And I am going to configure it so that it emits warnings to my log every time it goes through the retry. So this is now baked into every context that we create on the Bicycle database, right? We've got our Resiliency in here. So we can go to our Entity Framework controller and go find a little piece of Entity Framework code. In this case, we have using context equals entity framework.bicycle context, factory, and connection string. And into it, we do a little join. That's our query. You'll notice my habit of separating the query from the execution. That's a good practice. And if I wanted to make this even better, I could say as no tracking. And that would make it clear that I intended this to be read-only. And then I could then have my little method that returns my results as a chunk of JSON, which of course I set up here. We'll run all of these in a minute. So that's Entity Framework. We bake it into the context object, and then every time we new up an instance of that context, that policy gets applied. And that's great. ADO. So that's a little more convoluted. Essentially, what you do is you add poly, this is poly by the way, to your project. You add a little SQL retry policy. You have to give your poly policy a name. So I named it SQL retry policy. And I set up a policy where I said handle SQL exception and then wait and retry. And then the first time it'll wait 100 milliseconds, then 300, then 500. And then it will composite a message and emit it as a warning and tell us all about all the horrible things that went wrong. So now I have a poly retry policy. So this is just a standalone class. And unless you use it, it doesn't do anything. We can't wire it into anything. But we can use it in the scope of our code. So let's go to our ADO controller. And in our ADO controller, let's see it in action. So we build up a nice join SQL statement. It's the same as the Entity Framework one. It's just a lot more verbose. And we say, okay, I want to new up a poly instance, and I want to feed it the logger I'm currently using so that it has a place to log. And then I just wrap my normal ADO calls in poly execute. So I created a SQL retry policy object called poly, and I say poly execute an anonymous function, and I say my data table is equal to the Blitzkrieg software SQL helper, and I pass it in the connection string the SQL, and null means I'm not passing in any parameters. I call to dictionary on the object, and then I return it back. And so you can see that poly in the case where you're using ADO, or indeed any other connection-oriented protocol that doesn't have a way for you to embed a retry policy, what you do is you wrap your call in poly. So you can make retry policies for Redis. You can make retry policies for Cosmos DB. You can make retry policies for anything you want. And the secret is you make policy objects and then you use poly and wrap the calls. Here's another example where we're using poly to wrap the execution of a stored procedure. But again, my stored procedure invocation in ADO.NET vis-a-vis the Blitzkrieg Software SQL Helper library is just the same as I would write before, and I get my resiliency by wrapping it in a poly execute. Let's run our demo and execute some of these methods. All right, let's start with ADO and get a sample of customer order product, and there you go. There is the return of customer order product as I queried it. In this case, this is a partial disorder. I only got back the first row, which was a narrow wheel, for no reason other than I just felt like that's what I wanted to do. Let's go and try our entity framework. And this time we'll have entity framework return all the rows for this order. And you can see that we returned a little JSON body, and we have not only our wheel narrow, but we have our 24-inch wheel narrow as well. Here's our demo of calling our HTTP REST endpoint. And you can see we got a big block of JSON back, which is what we intended. And if there'd been a problem, it would have done the retries. So there you go, resiliency.